All right, so this is a video I've been wanting to do for a couple of years now. This is my benchtop custom power supply that I built. And it's, you know, the standard, take a PC power supply and build a front panel for it and everything, and then you've got a cool power supply. With all the money I spent on it, I probably could have just bought a power supply. But this was the whole experience of building it. I needed a lot of the parts and stuff anyways to have on hand. So this was the end result. So I'll show you a couple ways that I use it and how it works, and then we'll take each of these apart and look at the internals. So this is just one of those goofy little eBay projects, and these are good projects if you are looking to learn how to solder. It's a good experience. So this is just one of those, so you press the button and then it goes to a random LED. Should go to a random LED every time. And that's being powered by the 5 volts. So each of these is on, there's a relay inside and it switches both the ground and power, and they're controlled by these switches. So you got 5 volts here. We've got 12 volts down here, 9 volts, which is a PC power supply does not provide, and I'll show you how I did that, and then the 3.3 volts here. And this is the main power switch here that turns the entire thing on and off. Up top was just kind of an add-on I did later because I realized this panel did not have room for these AND meters here. And these are typically available on eBay, fairly cheap. I've actually gotten a couple different versions over the years when I've ordered them. Some of these have a little more flicker in the LED. You know, it's with these, they're cheap Chinese knockoff kind of things. You never really know what you're going to get. They may look exactly the same, but they're, you know, I've noticed differences in the board. And like I said, the LEDs tend to have more of a flicker in some of them. So your results may vary. So these little guys have 5 wires. So this is your AND meter here, so you can read current. So this black wire is your negative, and that's actually already shorted to ground on here. And then this is going to go to the negative of your device that you're measuring. Then you've got red and black that supplies power to the meter. Anything above 5 volts up to, I don't remember the upper limit on these, but it needs about 5 volts to start working okay. And then, but you can't go up to 12 easily. And then the yellow wire is your voltage for the volt readout at the top. So the way I would use this, this provides power to the top part, but it's just 5 volts for the meters to keep those going, and then 12 volts actually goes into the voltage regulator for the adjustable side. But we'll get to that. So what we can do, I'm going to use a Lego motor to illustrate this, and I do have a Lego channel. I tend to do some electronics things there and modifications. So I have a lot of fun over there. So I'm going to take the 9 volt ground, and I'm going to go to the N here. This was labeled a little bit arbitrarily, just because I wanted to make sure I knew what I was hooking it to. That's all that really matters. I'm going to take 9 volts here, and I'm using blue for 9 volts. I try to keep everything a little bit color coordinated. So 5 is red, 12 is yellow, just like on an actual power supply. The 3.3 is usually a orange wire, but whatever. I don't know if I ever found orange binding posts and banana plugs like these, but so I just went with green. So this is going to be the volt in, and then this is going to be the ground that actually goes to what we're measuring. So now, if I turn on the 9 volts, you can see we've got a volt reading here of 9 volts, and it's pulling about 0.6 amps right now. So I can actually, if I start to stall the motor, you can see it jumps up a good bit. And then we also have the adjustable side here. So I can hook it up just like that. And then I've got a switch here for power. So that's 5 volts. And this is a 10-turn potentiometer, which means it turns and turns and turns. But that allows you to really dial in exactly what you want. So we're at 3.3. Right on at the 9. And you can even go a little higher. So that's the adjustable. I'll knock that down to 5 just in case I don't hook anything up and damage it later. So that's how it works and how it can be used. And then I'm going to go ahead and take the shells of these apart, and we'll look inside and see how it's all wired up in there. And something I forgot to mention is these are always good to have. We've got some jumpers here, and these can actually be plugged in on both sides, so you can stack these. These are stackable. These are just a banana plug to alligator clips. Lots more alligator clips. These are voltmeter leads, but you can also use these with the power supply. This was something I made, and it's actually to power something that needs a 9-volt battery. Then of course I got blue for the 9-volt. And this is actually wired backwards because this is going to plug into you know, the input on a device. So like when I cut this lead, the black wire ends up being the positive because of the way that these snap connectors work. So that's just something to keep in mind. And then again here, just like I used on that little board, these are great. They just have a little, let's see if I can get it to focus, a little hook that goes out, and it's spring loaded, so it'll just grab onto, maybe if you just want to grab onto the leg of a transistor or something, you can do that. All right, so let's get taking this apart. So first I'm going to turn the power off, obviously, and remove these cables in the front. And I'm actually going to go ahead and pull these. Really, I could have ran the wires through the inside between them or something like that, but this makes it easy to take everything apart and work on it. So these two halves are held in place with, this is that 3M plastic kind of like Velcro, but I've already pre-loosened it because it holds very tight. I probably should have used less than this, but you know, lesson learned. These cases I got from Jameco. They're not terribly expensive, but I really like them. And then the two halves are held together with 2 screws. We'll try not to make you too motion sick with all this. So this is what I've got inside. This is a, what is this, a Flex ATX, whatever it is, form factor PC power supply. So all the wires come out in this bundle here, and they get broken out on this terminal strip here. And you may notice some of these have multiple wires going into the same connector or stacked connectors. And there's a reason I did that. Throughout this project, I actually tried to do the calculations for the gauge of the wire and how much power I wanted to be able to go to each output. So I did kind of double up on some of these just to try to get it as good as possible. So the terminal strips rated for like, 10, 15 amps. That's no problem. There's a relay that controls each one. So you got 3.3, 5, and 12, and then the 9-volt back here. And these are rated for, I don't remember the exact rating. I think it may be 5 amps. I think that's kind of what I was shooting for, to be able to source 5 amps from each of these or something like that. I typically don't do very high power stuff, so it wasn't really that big of an issue. Let's turn the power on. This will probably be a little flickery here, but that, oh yeah, it's upside down. That's reading 9 volts. And it's just a cheap voltage regulator I got online. It is adjustable, but I've just got it set to 9 volts. So this tiny little thing here on the potentiometer, that's how you dial in what you want your output voltage to be. And like I said, I just keep that at 9 volts. These are 12 volt lights I got from Jameco. I think most of it came from Jameco except for the binding posts. I got these in lots somewhere on eBay and somewhere on Amazon. I had to shop around a little bit, especially like certain colors are harder to find sometimes. White seems to be a hard one to find, which I have used in a couple projects. So yeah, let's flip on the 12 volts, and you can see the contacts on the relay. And I do switch both the positive and negative separately through the relay, because I had issues when I didn't do that. I had power feeding back like through the light to some, if I hooked things up in a certain way, I had issues. So that's why I did it that way. And the relays do have a LED on board. That's pretty cool. I got these in a lot on eBay. I got like 10 of them for, I don't remember exactly what I paid for it. So really, there's not much to it, but it did take quite a while to make all of these connections. So, but for me, it was a fun project. I just put on a movie or something and start going to town. Something else I do, and you may notice here, these are all soldered connections, because I don't trust these on their own. Even though heating them up does weaken the plastic a little bit, I feel better with a soldered connection. And something else I'll mention, you see me touching around in here, all of this is 12 volts or under. This is where the 110 comes in and goes to the power supply. That's the only high voltage that's in here. And that is a repurposed or recycled power plug probably from another power supply, maybe a larger one. Just because I have these plugs all over the place. I have extenders and splitters, so I tend to use you know, these connectors on a lot of my projects when I need 110 volts. So that's pretty much it for this half. Now let's look at the other side with the adjustable voltages and everything. One other thing I'll mention, the reason I use this terminal strip is all of these connections can actually be taken off. And this whole front panel can be taken off, made changes to, and then put back together. So I try to keep things fairly modular and serviceable as I go. You know, I like all these are labeled for what voltages they go to, all that kind of thing. And all of the colors of the wires inside have some meaning behind them. And it just makes it so much easier if you want to make any changes in the future. All right, now we're on to the second half, and same thing here, just 2 screws to take the shell apart. And like I said, this is definitely the simpler side, but there's room for expanding later on if I wanted to. So we've got the same thing we've got one of these voltage regulators that I got on eBay, and you'll see here these are the 3 wires. This is where that potentiometer was, that little blue box on the other one with the tiny flathead screw. And what I've done is I've taken those 3 wires, and this is a 10-turn potentiometer I got on eBay. And so that it's the same kind of thing. Instead of turning that little screw, you can turn this. And again, the reason for the 10-turn one that just turns and turns and turns is so you can get much more granular, a fine adjustment on there. And then of course we've got our relay that controls the outputs there, and a small little terminal strip here. And again, this whole thing will slide out so it can be worked on, but these connections are a little tight, so but it is just as serviceable as the other one, much more so because there's less room, more room. And yeah, these panel mount volt and ammeters, they're a little bit of a pain. I used a Dremel and just tried to cut the best squares that I could. And getting all these on the front was a little bit of fun too. You know, breaking out the ruler and the square and trying to line things up the best I could, and then hoping the drill bit doesn't drift too far. It takes a little bit of practice, but I didn't make too many mistakes. I always knew if I really goofed up, I could use the back panel, put the bad side on the back panel, maybe put some tape over the hole or something, and then have a fresh one to work from. But these do come in 2 different sizes, and I've used different ones for different projects. I guess I can try to link some of this stuff in the description if anybody's interested. But you know, a power supply like this, it's a good first project. You're not really designing anything crazy. You're just making connections and switches for your power and everything. And then any future projects you can do, you can use this to test it. So that's why I've been building these for 20 years over that, you know, since I was a kid. So it's always been a very fun and enjoyable project to do, and very useful. So I hope you guys enjoyed. Again, I'm not sure what I'm doing with this channel. You know, I've done some music stuff, some electronic stuff, some Lego stuff. My main focus right now is Battery Powered Bricks, my Lego YouTube channel. And like I said, I do some electronic things there too as well. But for now, I do want to start uploading to this channel again now that I've kind of learned a lot about YouTube and how to make better videos. And it's just good experience for me to keep it going. So thanks for watching, and maybe we'll see you in the next one.